Okay, 5.5 is us determining absolute extrema from the candidates test. I know it doesn't say test, but that's what it is. It's the candidates test. So it says the critical points give us possibilities of finding a max or min. The ends of the interval or the endpoints give us other possibilities of finding a max or min. So what this tells us is that we could get a possible maximum or minimum from critical points and endpoints. Okay. So what that means is I'm going to draw a graph. Okay. Each of the points on the end of an interval that will be given to us are our endpoints. And then every time our graph goes from increasing to decreasing or decreasing from increasing, we know we have critical points. And then also at this cusp where the derivative would not exist, we have a critical point. So this is saying at all of those points, okay, there is a possible maximum and minimum value. Okay. So for the candidates test, in order to find an absolute extrema, we are going to find the critical points and then test the endpoints, which will be given to us in an interval. Okay, so number 1 says find the absolute maximum value and the absolute minimum value of the function on the interval -1/2 to 4. Remember to show that you've checked all the candidates. So our first step is to find the critical points, and we do that by taking the derivative. So what would be the derivative of f of x? 3x squared minus 6x. We would set that equal to 0 to find our critical values, our critical points. I would take out a GCF of 3x, and I'm left with x minus 2, which means I have 2 possible critical points, one at x equals 0, and the other at x equals 2. Right? We set 3x equal to 0, we get 0. We set x minus 2 equal to 0, and we get positive 2. Okay. So from there, we're going to do the candidates test, and what that is we're going to plug in the endpoints into the original function, and then we're going to plug the critical points into the original function. And what we're looking for is the highest and lowest value for us to find the absolute maximum and the absolute minimum. So we're plugging in f of -1/2, f of 0, f of 2, and f of 4. So those 4 values. So on Desmos, I would type in the function. So x cubed minus 3x squared plus 1. And then on the next line, we're going to plug in each individual value. So we have f of -1/2, which gives us 0.125. So I'm going to write that down. We know if we plug in 0, we're going to get 1. Hopefully we don't need Desmos for that. Okay, and then we're going to plug in f of 2, and we get -3. And then f of 4, and we get 17. Okay. So from here, we can say that the absolute max value is, which number is the highest? Of 17, right? So we say the absolute maximum value is 17 at x equals 4. Okay, what about the absolute minimum? Is -3 at x equals 2. And those would be our answers. Okay, which means I no longer need Desmos anymore. Okay, so just going back to what we did, we first found critical points. We plugged in critical points and endpoints into f of x. Okay, and we did this using Desmos. Okay. And then to find the absolute maximum value, we looked at the largest y. And then to find the absolute minimum value, we looked at the smallest y. Okay, any questions so far? Okay. Now it's a little different if we're looking at a graph. So it says, looking at the graph of f prime, we can identify relative extrema at the x-intercepts. Can you find the x-coordinate of the absolute maximum and the absolute minimum? So it's still asking us to find the absolute maximum and the absolute minimum. And then it just told us that since this is the graph of the derivative, we know that all the relative extrema is going to be at the x-intercepts. Okay, so we have right here, and right here. Okay, relative extrema. Okay, before we continue this, we also know that everything above that x-axis tells us what? That f is increasing. So we would say f prime of x is greater than 0, means that f is increasing. And when would f be decreasing? Less than 0. So f prime of x is less than 0, means that f is decreasing. Okay. So instead of outlining the graph like we do before to identify what is above or below that x-axis, I'm going to shade in the area. Okay, so again, for when f is increasing, that is everything above the x-axis. Okay. And when f is decreasing, this is everything below the x-axis. So based off of this, we're able to draw a rough sketch of the original function f. And the reason why we're shading in the area is because this area here, since it's the largest area, tells us that our function is rapidly increasing. Okay? Compared to this small increasing area, it's still increasing, but is it increasing as fast as the first one? No. Okay. And then this one below the x-axis is saying that it is decreasing, but is this decreasing faster or slower than this is increasing? Faster, right? Because it has a larger area. Okay, so we keep saying the word area because this is going to lead us into Unit 6 when we talk about integration. Okay, for now, we're just going to talk about large area means rapidly increasing. Small area means still increasing, just not as fast. Okay, So if I was to draw what the function f looks like, okay, from the interval -3 to 1, I just said that this is rapidly increasing. So I'm going to have something that starts here at -3, rapidly increases all the way until I get to 1. Okay. Then I'm going to decrease. Okay. And then when I increase that last time, you said it's smaller than the rate in which I was decreasing, so I'm only going to go up a little bit. Okay, so this is 4, my endpoint, and then this cusp that I just created is 3. Now I'll zoom that in here. So bear with me on my sketch. But those are my endpoints, and these are my 2 possible critical points. Okay. So, looking at this rough sketch of the graph F, where would you say the absolute minimum is? At -3. Okay, so we would say the absolute minimum is at x equals -3 because it is the lowest value. Okay, it's the one that's closest to the bottom. Okay, what would you say is the absolute maximum? Good, at x equals 1 because it's the highest value. So the absolute maximum is at x equals 1. Okay, and that is, I shouldn't have wrote so small, but that is the answer. Because that's all it was asking us to find was the absolute maximum and the absolute minimum. So we had to look at the areas where f was increasing and where f was decreasing to help us draw our function of f. And then from there, based on where it is, determine if it's an absolute maximum or absolute minimum.